So in this lecture we will see how to draw graph of cubic function when two roots are same. I mean you are having all the three roots here, value of two roots are equal and one root is distinct. Okay, three real roots, two equal and one distinct. Okay, I won't go here into much detail, just a brief of how to draw graph of such functions. Okay, so first of all draw the coordinate axis. Okay, now what do you mean by two equal and one distinct? I am not writing the whole function here. Okay, I am just denoting roots by alpha and beta. Okay, like the previous values are 1, 2, 3. Here I am not denoting any specific value, just by symbols. Two roots are equal, so they will be alpha, and one is different, it will be beta. Roots means simply value of x when you put the whole expression to 0. Okay, so first of all, alpha here, suppose you need to plot a graph for it. Okay, so in how many points it will cut the x-axis? It will cut x-axis at 2 points. Okay, these 2 points will be, suppose here alpha and then beta and then beta. Okay, the 2 points will be here only. Okay, so now if you need to plot a graph for this function, what would you do? So for plotting the graph, I am assuming here the coefficient of x cube to be greater than 0. Okay, coefficient of x cube is positive. Okay, so if you need to plot a graph for it, what is the condition? As I explained earlier, when x is tending to infinity, y will tend to infinity when a coefficient of x cube is positive. So your graph would start from here simply. Okay, now when x cube will be negative, this will also be negative. Okay, as I explained, so graph would end like somewhat here. Okay, now if you have to draw the graph, okay, here you are having only basically two roots equal, and here you are having one different root. Okay, two equal and one different. So if you need to plot the graph, you will join here like this. Okay, now when two roots are equal, graph won't go down actually. It will be simply like this way, and then suppose beta is not here, go like this. Okay, suppose beta is here. Okay, so graph would actually curve from the point where the two roots are equal. Okay, it won't go down like this. Okay, when coefficient of x cube will be negative, then what would be the behavior of graph? It would simply look like, okay, here coefficient of, suppose I am assuming coefficient of x cube as negative. Okay, not here exactly. Suppose I keep coefficient as negative there. Okay, for this one. Okay, so what will the roots? Roots will be beta, alpha and alpha. Okay, so now when x is negative, y will be positive. We know it. Okay, and when x is positive, y will be negative. So it will go somewhere here, because x is positive, y is negative here, and when here x is negative, y will be positive. So it would go from here. So how would the graph look like? Graph would be simply, it will begin from here, then it will go here, and now it won't go upwards because it has to reach this point, because we know at x equal to infinity y is minus infinity. So it will go like this. Okay, okay, the graph would curve from this point only. Like here it curved this way, here it would curve like this way. Okay, for example, suppose if you take function of x as x minus 1 into x minus 2 cube. Okay, function of x is x minus 1 into x minus 2 cube. What is beta here? Beta is 1 and x minus 2 square. Sorry, the function is x minus 1 into x minus 2 square. Okay, so what is beta here? Beta here is 1. Okay, because it is a distinct one. I have taken a distinct root to be beta. And what is alpha here? Alpha here is 2. Okay, so this will be simply 2 comma 2 and this will be 1. So graph would go this way, and similarly for here, if you apply minus sign here, okay, then the function would become negative. Okay, so I mean coefficient of x cube will be negative basically. So the pattern of the graph would be this way, where beta will be equal to 1 and alpha will be equal to 2. Okay, so it was just a real example of how the cubic function would look like. Okay, so now we'll see what happens when all the 3 roots are actually equal. Okay, I mean you are having the 3 roots equal. Okay, so we'll see here. So how will the function look like when it is having 3 roots and all are equal? Suppose it is of the form y equal to x minus 3. Okay, we can write it as x minus 3, x minus 3, x minus 3. So when you will equate it to 0, what will you get as roots? You would simply get as x equal to 3, 3 and 3. Okay, so the roots would be simply 3, 3, 3, all being equal. Okay, here coefficient of x cube will be positive when you expand. Okay, so if coefficient is positive. Okay, now suppose we draw its graph. How would the graph look like? Okay, it would cut the axis at one point only, 3. Okay, now since coefficient of x cube is positive, when the value of x will be infinity, y will be infinity, and when x is minus infinity, y will be minus infinity. So the 2 extreme points would be here and here somewhere. Okay, so graph would simply go like this. Okay, because it has to cross here also and cross here also. So the graph can't curve actually. It will go in this manner only. Okay, suppose the function is y equal to minus x minus 3 cube. Now how the graph would look like? What will be the change? Here coefficient is negative because of this minus sign. So the graph would simply look like, you first plot 3 here. Okay, then when x will be negative, y will be positive. When x will be positive, y will be negative because coefficient is negative. So from here and here, so the graph would simply be like this. Okay, going this way. Okay, because it can't have, because it has to reach here. We know that if x is large number, then y has to be negative of that large number, and if x is negative here, y has to be positive of rather magnitude. So this will go. Quadratic function means the polynomial having degree 4. Okay, polynomial is having degree 4 simply. Okay, so what will be the form of the function? It would be simply like fx is equal to ax4 plus bx cube plus cx square plus dx plus e. Okay, so like linear had 1 root, quadratic 2 roots, cubic 3 roots. How many roots will this function have? This will have 4 roots. Okay, And what can be the possibilities for this? The possibility can be simply as I told you, imaginary roots always exist in pairs. So all 4 can be real. Okay, 4 real, 0 imaginary, then 2 real, 2 imaginary, then 0 real, 4 imaginary. Okay, anything can be the possibilities, and you can have multiple possibilities here also. When these 4 are real, and when 4 are equal, 3 are equal, but we won't go into much detail because graph of cubic quartic function is not as important from the competitive point of view. So we will study just a basic form where 4 roots are real, okay, and they are distinct. Okay, for the rest of the condition you can do it by yourself also, or otherwise it's not necessary right much. Okay, so we will see the condition where 4 are distinct, 4 roots are distinct and are real. Okay, so suppose you take this example. Okay, sometimes I am writing y, sometimes I am writing fx. That is same only. Fx means the value of y only. Okay, so x minus 1, x minus 2, x minus 3 and x minus 4. So what are the roots here? When you will equate the whole function to 0, you will get roots as 1, 2, 3 and 4. Okay, so when you multiply all the terms, the coefficient of x4 will be positive because in each term, in each bracket, x is having positive coefficient. Okay, so coefficient of x4 will be positive here. When you multiply, you can check it by yourself. Okay, so in this form also, when you take suppose very large number like x equal to 35 lakhs, okay, then 35 to the power 4 will be much more greater than 35 to the power 3, and even addition of all these. Okay, because the power here is the highest. So what will be the sign of the function at a very large number? That will totally depend on value of x to the power 4. Whether the sign of x to the power is negative, then the whole function will have a negative value at large number. When sign of this function will be positive, then the value of whole function will be positive at very large number. Okay, like we saw in the case of cube. So similarly here also. So in any case, suppose you take x equal to 35 lakhs, what would this become? This would simply become 35 to the power 4 and plus the rest terms. Okay, so here what do you find? 35 to the power 4 is always positive. Okay, so it will be positive. Okay, now suppose you take x equal to minus 35 then. What will the sign of x to the power 4? It will simply become minus 35 to the power 4. This will again come out to be 35 to the power 4. Okay, so when coefficient of x to the power 4 will be positive, what you find? Then 35 to the power 4 is also positive. Okay, so basically for very large number, if x tending to infinity, okay, when coefficient of x cube is positive, I am considering here positive coefficient. When coefficient of x to the power 4 is positive, then if suppose x is very large positive number suppose x is tending to infinity, then y will be positive only, and if x is very large number minus infinity, then also minus 35 to the power 4 would become simply 35 to the power 4. Okay, so it will be infinity only, unlike in x cube where you had here, if here you had infinity, here you had minus infinity, but here since x to the power 4 will be always even, so it would always turn out to be positive. For which case? For the case when coefficient of x to the power 4 is positive. Okay, that means two extreme point will be like this only, I mean from top only. Okay, so now we will see how to plot the graph of this function. Okay, Okay, first of all just plot here 4 points 1, 2, 3 and 4. Okay, okay, so you know here coefficient of x cube is x to the power 4 is positive. So when x will tend to infinity, y will also tend to infinity. When x will tend to minus infinity, y will tend to infinity only. Because if you put here minus here, then minus to the power 4 would automatically become positive. So that at both the ways graph would start from here only. Okay. So it would simply look like this way, then this way, then this way, then. Okay, graph of this function at 1, 2, 3, 4. This way the function when coefficient is positive. Okay, so I am assuming here 4 real roots and all the roots are distinct. Okay, now we'll see the graph, how would be the behavior of graph when, okay, this would go simply this way, okay, upwards only. Now we will see the behavior of graph when coefficient of x to the power 4 is negative. Suppose you minus sign here, you put minus sign here, okay? When you put minus sign here, what happens? Coefficient becomes negative. If I have to consider the case, coefficient becomes negative. Okay, I mean a will be negative. Okay, so when x will be, suppose very large number. Now I am not taking 35 lakhs. Suppose I am taking infinity only. Okay, because you know what very large number means. Okay, when x is equal to infinity, what would you get simply? Suppose you put x equal to infinity here, you would have infinity cube, infinity to the power 4, okay, and minus sign outside because coefficient of x to the power 4 is negative. So the value of 4 function will depend on value of x to the power 4 only. So this will turn out to be minus infinity. Okay, when x will be minus infinity, what would the function become? Function would simply become minus and minus infinity to the power 4. Okay, that would again turn out to be minus infinity. Okay, so what we see here, since x is having the power 4, whatever you put in place of x, it will be always positive. So the sign of the function is dependent on x to the power 4. So basically the sign gets dependent on coefficient of x to the power 4, because what will be the coefficient of x to the power 4? The function will assume that sign only. Okay, so when you put minus sign here, then what if you take a very large number also in both positive and negative direction, the function would be negative only. Okay, getting it? Okay, now if you need to plot the graph, just plot the points first. 1, 2, 3, 4. Okay, you have this condition here, when x is large, y is negative large, when x is large again, y is negative large. Okay, so at both the extreme points, function would be simply this way. When x is large, y will be negative, when x is large, y will be negative. Okay, we have seen it. So function would be like, it will start from here, then here, then here, and then like this. Okay, because it need to cut axis at 4 points because of the 4 roots. 4 roots means it will get axis at 4 points. And at very large number, since coefficient of x is negative here, the whole this term, which comprises of x to the power 4, will turn out to be negative. And the sign of the whole function will depend on this only, because it is having the largest power of x, as I have explained earlier. So the graph would look like this way, and when the coefficient will be positive, we have drawn the graph. It will start from this way. Okay. So this graph we assume for the function which is having all the roots real and distinct. Okay. So if you want to draw a graph of higher degree also, like for x to the power 5, x to the power 6, you can simply follow this technique and plot the graph. Okay. Also, I am not plotting here graph for the condition when two roots will be equal, two roots will be distinct. I am leaving it up to you. You can try it yourself, and if you don't want to try, then it's okay, because such complicated graph won't come in the aptitude examination. Okay. Just you need to have the basic idea of this only. Okay. So I hope cubic and quadratic function and quadratic is clear. So in the next class we will see just the graph of x square, x cube and x to the power 4, and then we will see graph of some basic irrational functions like 1 by x, 1 by x square, 1 by x cube. Okay.
For more videos, click the subscribe button below.